Okay, so for everyone that's here, I'm going to go through some meeting logistics before we get started. Welcome to day one. This link that you used to join today is the same link for every other day. So save it somewhere where you can easily get it so you can join again tomorrow. If you have questions for speakers, please feel free to type them into the chat. It's very helpful if you type the speaker's name. So if Jan is speaking, you can type Jan and then follow with the question so we know who you're directing it to. Otherwise, we'll make an educated guess. There are designated Q&A sessions during the day. We'll proctor the questions to the speakers at that time. So don't worry about if it gets lost. We're copying and pasting them from chat. You can also type some comments and you can use the reactions feature at the bottom. I think there's hands clapping and raise hands, and just remember to lower them if you do use that. Today's continuing education, we have certified crop advisor, 1.5 hours of crop management. At the end of the meeting today, a QR code will be displayed. You just have to open the app and take a picture and it'll automatically log you in. If you don't have the app, you don't know what I'm talking about, that's not a problem. All you have to do is email ANR program support at ucanr.edu and we can get you signed in as well. That again will be held at the end of the day, so make sure you stay logged in all day long and we'll get you your credit. And so I think I can turn it over now to Jan for some welcome. And I don't know if Jan, if you have any slides for this section.
No, I don't. Thank you, Kelly. Hello, everybody, and welcome. We really appreciate that you were able to join us today. As Kelly mentioned, my name is Jan Gonzales. I'm a program coordinator, community education specialist with the University of California Cooperative Extension here in the San Diego County office. I am currently primarily working on the Climate Resilient Agriculture Program, which is intending to help growers understand, adapt to, or mitigate the impacts of climate and weather, severe weather, to the farming enterprise, also to help sequester carbon, reduce greenhouse gas emissions. We have a very unique agriculture and farming environment here in San Diego County. So it's not one process or strategy works for everybody. And we're here to help you navigate what the best strategies for your operation might be. It's the Symposium. This is the third year that we've held it. It's been a different format each year due to the pandemic last year. So essentially, overall, we're just trying to bring all stakeholders together to understand what the impacts of climate and extreme weather will be to our local agriculture industry and how we can help our growers remain sustainable and more resilient than they already are. We have a immediate agenda change that I want to point out for today. It's a very last minute change. At 4 o'clock, we had scheduled Wildfire Preparedness for Agriculture presentation. They're not able to join us today, so I'm going to share some resources along that subject matter, but we'll probably just extend mostly the Q&A section since that was the last presentation for the day. We will have a resource related to that, a video resource that the Valley Center Fire Safe Council is preparing, and we'll be sharing with you in a couple of weeks. So more information about that coming. Before we move forward, I'd like to especially thank our UCANR Program Support Unit and the staff that are joining us today, Kelly McFarland and other staff. I'd also like to thank the County of San Diego. Our UCCE program is supported by the County of San Diego's Climate Action Plan program. So without further ado, I'd like to go ahead and turn it over to our County Director, Bachie.
All right, good afternoon, everyone. As Jan said, I'm the County Director and brand new for San Diego. I would like to express my sincere thanks and appreciation to Jan and her team and our program support team as well for hosting this webinar and of course providing all possible support for proper functionality of the virtual gathering. So on behalf of the UC Cooperative Extension San Diego County, it is my pleasure to welcome you all to this Climate Action and Agriculture Symposium. I would like to touch some basic areas. Why Climate Action and Agriculture Symposium? As you know, resilience for climatic adaptability and the tolerance for sustainable food production are at the top concerns of the nation, the state, counties, and the communities. As you have heard from the state as well, there is a strong prediction that California will be faced with drought challenges this year. So as those issues are top of our concerns, organizing such symposium and sharing best management practices to remediate or enhance productivity of our agriculture and natural ecosystem is a well-thought mission. I note that this symposium is missioned with various, diverse, and interrelated issues and topics ranging from trends and impacts of weather on agriculture, focusing on weather 2021, as you can see it in your agenda, heat, wind, freeze, and wind issues, wildlife, irrigation management and strategies, clean energy and the steps toward decarbonization, nitrogen balances and pest management in various cropping systems, and pest management, diverse areas including insects, weeds, and pathogens, and issues in organic farming, that is a huge concern for our organic growers, and strategies of climate smart agriculture and the technical assistance program are areas that this symposium is covering. Those and many other issues that will be addressed in this symposium, I believe will help us understand how we may play our respective roles in an effort to combat climate change and conserve and protect our ecosystem, enhance biodiversity, natural resources, and maintain sustainable food production that feeds global society. It is obvious that combating or mitigating those natural problems cannot be accomplished or solved individually. I believe it best requires collective action from all of us concerned institutions, stakeholders, growers, natural conservationists, scientists, and community educators. I'm glad to note that we are gathered here from various backgrounds and various responsibilities to deliver knowledge or gather needed education to enhance our roles. While wishing you the best for the 3 to 4 days of the symposium, and that you would have every success for the symposium to achieve the objective of this symposium, I believe that you will be in good hands for the moderation. Accordingly, I would like to yield it back to Janice. Thank you. Janice?
There we go. Thank you, Oli. We appreciate your opening comments. I would like to next introduce Hannah Gbeh. She is the Executive Director of the San Diego County Farm Bureau, and she'll provide some additional welcoming remarks. Thank you, Hannah.
Good afternoon. Can everybody hear me? I'm going to go with yes.
Yes.
Okay, good afternoon. My name is Hannah May. I'm the Executive Director of the San Diego County Farm Bureau. I am also the Administrator of the San Diego Region Irrigated Lands Group. It is not easy to be a farmer in San Diego County, so certainly I appreciate the opportunity to speak here today. You know, one of the reasons that it's not easy to operate an agricultural business in the county of San Diego is our high cost of land, our high cost of water, a labor shortage, extreme anti-agricultural rhetoric coming from our inner city areas, and a very complex regulatory environment. Our agricultural industry deserves special treatment and exemptions in educational opportunities because no other industries provide the socioeconomic benefits like agriculture does. Agriculture feeds humanity, it purifies the air you breathe, it sequesters carbon. Agriculture is aesthetically pleasing. It's also outstanding exercise for anybody that gardens. I know you know what I'm talking about. Agriculture provides economic benefits, and it is a crucial component for a vibrant and healthy community. We need to encourage agriculture, permit agriculture, and expand agriculture. And we need to provide our farmers with the tools to adapt and succeed. And we're very thankful for this symposium starting today to help do just that. So to provide a little background about what agriculture is like in San Diego County, in 2019, the direct economic output from agricultural production was $1.8 billion. We've got over 230,000 acres of agriculture, production agriculture here in the county of San Diego. We rank first in the nation in number of certified organic growers. We rank first in the nation in number of small farms, with 69% of our farms being between 1 and 9 acres in size. We've got over 5,000 farms in our county. And here in San Diego, our growers are always doing less with more because of all the constraints, and now with the extreme weather events, drought, wildfire that we deal with. Our highest commodity is ornamental trees and shrubs, the highest dollar value per acre, indoor flowering and foliage plants. Across the board, the commodity with the highest planted acreage in our county is avocados. And our #1 crop is nursery and cut flower products. Employment-wise, you know, we got a really interesting perspective based on the vaccine distributions that about 70,000 individuals in San Diego County are affiliated with the agricultural industry. So, you know, San Diego County is really a challenging place to do agriculture for many of these reasons that we mentioned. And then on top of that, we are faced with a drought, faced with wildfires. And so our farmers are always known for doing more with less. We grow those highest value dollar crops. We use minimal water and we use minimal inputs. We're shifting the products to meet the current demand. In San Diego County, we're known as a specialty crop county. We produce coffee and hemp, and dragon fruit, cherimoyas, whatever that highest value product is. Farmers are using the innovative farm equipment, they're using better seeds, we're turning to green energy and climate smart practices. Farmers throughout the nation, they're producing more food, renewable fuel, and fiber than ever before, while using less water, protecting against erosion and conserving more soil. We're avoiding nutrient loss, we're increasing wildlife habitat, and improving biodiversity. And beyond the statistics, San Diego growers really value our workforce, and we consistently provide high value industry wages, including things like retirement plans, health benefits, and more. The importance of protecting the long-term viability of San Diego agriculture is an issue of dire importance, because without this industry functioning at a high level of the entire existence of the human race is in jeopardy. You know, as they say, no farms, no food. So we are so excited that this symposium is launching today, because it's imperative that we set our agricultural community up for success in this ever-changing environmental, economic, and regulatory environment that we struggle with. So thank you so much, Jan, for allowing me to speak here today and being part of this event. We're really grateful for you offering this opportunity to the agricultural community.
Thank you, Hannah. We really appreciate you joining us today and offering those opening comments. Next up, I'd like to introduce Eric Snodgrass. He's the Principal Atmospheric Scientist with Nutrien Ag Solutions, And before I completely turn it over, I just want to let you know that if you'd like to have more information about each of our presenters this week, they can be found on the website. And I'll go ahead and put the link in the chat box for you. So Eric, are you ready?
I'm ready. Can you hear me okay?
Great. Yes. Thank you.
Yes. Well, I appreciate getting the opportunity to kick things off today. And as was stated, I'm an atmospheric scientist. I'm a weather weenie, and I study how the atmosphere impacts everything we do in production agriculture. And what I would like to spend some time focusing on today are what some of these longer term trends look like in terms of weather and climate. We'll discuss the upcoming season and some of the challenges that it poses. And along the way, I hope to kind of turn a few of you into weather nerds with me. Okay, so let's see what we can learn together and get this conference started with this high level overview of weather and its impact on production agriculture. So I'm gonna go ahead and share my screen here. And I'm gonna click play, and I'm gonna ask if somebody could just give me a verbal that you can see my screen okay.
Yep.
All right.
All good.
Now, you're looking at a map already at the beginning here of my talk and probably wondering, oh my goodness, what is this guy going to be doing to us for the next 25 or 30 minutes? I'm going to tell you what I watch every single day to understand how the atmosphere and its flow impacts production ag. And this map right here, although it might just look like a tie-dye colored map, this tells us exactly the position we're in right now. Now, what is it? It's last October 1st through this May 1st, looking at what we call the zonal jet stream level winds. Now, what does that mean? Zonal means west to east. And if we are going to go in to a growing season with adequate moisture in our mountains, in the snowpack, and in our reservoirs, we can't have a map that looks like this. It is one that the flow avoided California. Do you see the warmer colors here that went through Alaska into British Columbia? The warmer colors that were down here almost in the tropics, and the cooler colors that are here? This means that coming out of the Central Pacific into California, we had weak zonal winds. And if I could show you the flow in an anomalous way, in other words, the difference from normal, this is what you get. Now, I think every one of us on the call understands today that if our winds were anomalously out of the north or even out of the northeast throughout our wet season, we're going to suffer. And the problems have been long-standing. And I'd like to talk with you about some very important new updates in the world of weather that will help us understand this. You see, earlier in May, we had released from NOAA and the National Weather Service the new climate normals. Now, a climate normal is what happens when we take 30 years worth of data from over 15,000 weather stations, and we average those 30 years to give you a day-by-day, even an hour-by-hour normal or average for temperature and precipitation and many other atmospheric science variables. We're going to look at some annual changes because what we just did was we dropped off the 80s and added the 2010s to the data set. So it's now goes from 1991 to 2020. And the big changes we have to observe are shown in these graphics. And what I want you to first notice here is when you get out into the western part of the United States, kind of west of that line, I'll draw it on both images. We see that generally speaking, we've picked up about a half a degree to a degree by getting rid of the 80s and adding the 2010s. And our precipitation trend has been negative up to 10%. So what do these longer term shifts mean? Because when you get east of the Rockies, look at the northern plains, cooler trends. Look at how wet we are east of the Rocky Mountains versus the west. We need to understand what's driving this and what significant it has as we move forward. So these are the brand new normals in which we compare against. So if someone tells you, well, the normal high tomorrow is this is the data set from which that has been taken. Now, I want to talk to you about winter first. And yeah, we're going to look at a lot of cool maps. This is how I view the weather. It's the jet stream level flow. And what I want to hone in on is what's been changing right here in the Aleutian Islands. You see, the jet stream level winds have been shifting January through March, such that they've been pulling farther to the north toward Alaska and then dipping here into the Great Lakes and splitting around the state of California. And that split flow across the western part of the United States is the exact opposite of what we want to see. You see, it targets British Columbia, where we've noticed over the last 30 years an increase in snow in the Cascades and Northern Rockies. And it avoids much of the Intermountain West, including the Sierra Nevada, the Klamath Mountains, and the Great Basin. So we've seen a decrease in snowpack here and an increase in there because of these changes in the jet stream level winds. So we can add numbers to this so that we can remember what these shifts look like. Now we have data going back, well, almost 130 years. And these two graphics look at our wet season, the winter time, October to April. The one on the left shows you the precipitation trends, and the one on the right shows you the temperature trend. This is only for October through April, that 7-month time period. Now, the blue line at the very end shows you what the new climate normal data, where it came from. And what we notice here is that the 30-year trend is down 3.3 inches. So just looking at the last 30 years, we've seen a decrease compared to our longer term average. In terms of temperatures, our winter time period has increased on average about 1.5 degrees over the last 30 years, but it continues a longer term trend toward warmer. Now, I can provide statistics till I'm blue in the face, but really the question we want to answer to is, why is this happening? Because we also see it in summer. In the background there on the top, that is an image from a Nature article, a prestigious journal. I've got it linked there for you, that shows you what the longer term summer trends have been like. You see, as an atmospheric scientist, I am trained to recognize patterns. And one of the major pattern shifts we've seen has been an increase in ridging. That's where the jet stream goes north and the heat goes with it. Well, we've seen an increase of ridging here across the west, while we've seen more troughing over the east. And as a result, our May through October temperatures over the last 30 years have increased 3 degrees, and look at that upward trend. And it continues a trend that's been set, honestly, going back over the last 130 years. You see, we look at these data and we start to ask why, and there's a piece of that answer here. Now, we do not have enough time to go through an entire graduate level lecture on all the reasons why, but I'm gonna give you something to really hinge on here. This is a map showing you global ocean temperatures compared to normal today, well, yesterday. This was the data from yesterday. And what I want to do is I want to hone in on this area right in through here, the North Pacific. You see, in that box right there, we have been observing since the 70s a systematic increase such that in the top 100 meters, or the top 300 feet roughly, there has been an increase in total ocean heat content. And the net effect of that is to push the jet stream over it. It effectively increases the position of the jet stream more toward the north. And the jet stream dives down here over the Great Lakes. And the consequence of that is leading toward more split flow. And it's also leading to a reduction in the total moisture that comes into the west. So we get warmer temperatures and drier conditions. Now, this is only one of many, many reasons, but the atmosphere and the ocean are a coupled system and they work together. And so that longer term trend is significant. Now, what else is significant about this, and we're going to talk about this more in a few moments, is this right here. The cooler water off the West Coast, it hasn't been since 2012 that we've seen that much cooler weather just off the coast. So right there in the marine air layer along the coast, you've been experiencing some cooler weather, but the interior parts of California have not. We're going to talk about what the longer term implications of that will be in just a few moments. One last long-term statistic, here we go. There's an index we use to gauge drought. It's called the Palmer Drought Severity Index. And what I want to show you here is its 130-year trend. And you can see that it is decreasing. Now, a decreasing drought severity index means an increase in drought conditions. And what I want to stress here is that the biggest concern I have is over higher VPD. That is vapor pressure deficit. What we've been observing across the whole of the state of California is that we're getting an increase in the deficit of water vapor in the atmosphere. The net effect is the increase of temperature plus the lack of sustained moisture is leading to higher evapotranspiration rates and ultimately drying the vegetation and the soil out sooner. And these longer term statistics we need to understand and put numbers to, hard numbers to, so we can understand what the future change is going to look like. And what I want to do now in my remaining time is kind of showcase what happened this winter and then forecast this upcoming remainder of spring and summer and show you how things are going to continue to shift. Because last year put us through the ringer. This map, I love these maps. Take a look at what you've got. In every climate reporting district, there's a number. Remember, I've been sharing with you there's about 130 years worth of data. Well, all of 2020, looking across the state of California, you see numbers like 106, 122, 127, 124. That means on the rank scale, this would be in the top 5 driest years going back 130 years. And the Western drought last year was largely the consequence of a large ridge that sat right here. that ridge produced what we call ring of fire precipitation. And we had these high base thunderstorms, I'll show you one in just a few moments, that produced very little rain, but a lot of lightning. By the way, this ridge right here was responsible for guiding all of those tropical cyclones into the southeast. You see, it's all about deciphering the flow of the atmosphere throughout the year. And what it did, can you see the animation here? I hope it's playing smoothly for you. That's all smoke in the background there. In fact, let me pause that and just take you back. Oops, sorry. Let's watch this one more time, and then I'll pause it so we can see a little bit better. That's all smoke in the background. Here comes the sunset. There it is. Now you can see the smoke. But all of these storms are within that ring of fire pattern. And some of the storms, as I said, have very high bases on them, which means they don't produce a lot of rainfall that gets to the ground. But what they do produce is a lot of lightning, which induced a lot of fires. We even saw throughout the state of California, getting even over on the other side of the Sierra Nevada mountains into Nevada, a lot of the circulation of these smaller scale storms spin up huge fiery vortexes like this. Incredible. I've never seen stuff like this out there in the West as captured on video here. But the end result was our worst day, if you had to have me pick out a day or a weekend, was Labor Day weekend. This satellite animation goes through Labor Day weekend and shows you the extent of the smoke, under which was more than 8.2 million total acres that were burned. The problem through Labor Day was that the wind direction, as you see in this animation here, was about to shift and come out of the east. And those winds that come from the east, they descend over the mountains, compressionally warm and get very, very dry. We know them. That adiabatic compression, we give it a name, right? It's the Santa Ana wind. And it can produce near 0% relative humidity on 60, 70, 80 plus mile an hour winds, rapidly drying the vegetation and increasing our fire threat. Well, I was monitoring the smoke very carefully. I'm over here in Illinois watching your smoke because it spread all the way across the United States. And the smoke that came through on that Labor Day weekend getting pushed out into the Pacific Ocean covered San Francisco, for example. I wonder if you saw this in the news last year. Late morning with the smoke over San Francisco, the street lights stayed on because the only light that survived the trip through the very smoky atmosphere was the red light here, giving us this very eerie presence in the atmosphere here as the sun was coming up on this morning here, Labor Day weekend in San Francisco. These fires weren't just in California, just to make this clear, because we're going to talk about drought in a few moments. Drought extended all throughout the Intermountain West, and in Colorado, the Cameron Peak fire here, it put up smoke that we traced all the way into the North Atlantic. That's how bad these fires were. Your Western US fires last year were just one of 22 separate billion-dollar weather disasters, making 2020 the most expensive year in terms of separate billion-dollar disasters. So the whole country was feeling the effect of the pattern established in the West. Well, we tried to go through winter to recover, and this map shows us how we didn't do that. You're looking here at a map showing snowfall anomaly. So these colors here represent where we were in deficit for snow, and the bluer colors represent where we were in excess. Throughout the Sierra Nevada, even getting north into the Klamath Mountains, some parts of the Sierra Nevada were over 100 inches in deficit. Now, we had some bigger snows down here surrounding the LA Basin. That happened. But remember, it's the snowpack to the north that's going to fill the reservoirs. And when you finish the year with only 60 to 70 to maybe up to 80% of normal snowfall, that leaves a lot on the table. You say, why didn't we get the late season snowpack? Comes back to the very first thing I talked to you about. The flow avoided California. Do you see the split there? It was very weak right here along the West Coast as the flow went into Canada, and it zipped down here through parts of Mexico, ending up over in the eastern United States. So we had no miracle March. And who had it? Well, it wasn't us, where we got less than 50% of our normal March precipitation. And look how very dry it was down here in the desert compared to normal. It was the Central Plains. It was Nebraska that got the miracle March, where they were having their wettest March on record going back 129 years. You see, the drought has been compounding ever since then. And if we just look at the longer term statistic, let's head down here to the San Joaquin Valley, into the LA Basin, and down to San Diego. We had a top 5 driest October to April on record. This is what we have going into this upcoming season. So it is no surprise to anybody in the call today that the latest drought monitor shows extensive, severe to extreme to exceptional drought. That's the deepest shading through here across the West. And I've been monitoring the changes in this map, and the drought monitor change map shows that over the last 2 months, we have seen up to a 3-class degradation through the Central Valley of California along the coast. And down here in the LA Basin towards San Diego, we've had a 1-class degradation. The improvement's been in the Southern Plains right in through this area. So keeping all this in the back of our minds, what did April and May give us so far? Well, it's given us the driest such time period on record into parts of the Mojave Desert, cutting down here towards San Diego. You can see the statistics as plain as day. We have continued to miss out on any late season moisture return to the western part of the United States. So earlier when we were talking in the introduction about the risk of drought in this upcoming season, it's not only there, but it's also in a lack of our soil moisture values. You see, this map compares to normal what our soil moisture is in the top 40 centimeters, or roughly 16 inches. And we can see that throughout the West, and it's also in the East as well, folks. Just keep an eye on this drought situation here too. But we're sitting somewhere between 10% to 2% of normal soil moisture through the Central Valley, getting down to where we're making measurements down here in Southern California, but this extends into the Pacific Northwest as well. When we have drought in the western part of the United States, it tends to come in big helpings and last multiple years, like 2001 to 2004, or 2007 to 2010, or the 2012 to 2017 drought. And here we sit now building drought across the western part of the United States, and there's concern that it's going to continue to build. Almost every reporting station throughout California measured half of its normal moisture this past winter. For example, in the Northern Sierra, we had 22 inches. We normally have close to 50. Head south of there into the San Joaquin precipitation stations, normal would be about 35. We had 18.2. In the Tulare Basin, we're looking at 9.6, where normal would have been about 27 inches. So the drought extended much to a greater extent the farther south we go. And our reservoirs are hurting because of this. Look at the big ones in the north. Let's just focus on the north for a moment here. You can see the ones farther to the south, but Lake Oroville, Lake Shasta, sitting somewhere between 40 and 45% of full pool. And so the water restrictions as a result of this are going to plague us through the remainder of this year. So let's forecast and then get to some questions. Our next 10 days, well, this map shows precipitation anomalies. See where the moisture is targeting? The Cascades, through the Northern Rockies here in British Columbia. We're continuing to see our drier than normal conditions extend throughout much of California. Very wet here, but the flash drought situation continues to get worse over the southeast, just to kind of give us a whole US perspective. And in terms of temperatures, I hope that we've enjoyed the last week where we've had some cooler weather here in the state of California throughout the Great Basin, because over the next 5 days, as we get into Memorial Day weekend, that cooler air moves east and north. And watch what happens as I show you now the next 5 days and going out there today 10 through 15. I expect temperatures throughout the whole of the state of California to be anywhere between 10 and 25 degrees above average. That is going to increase our evaporation rates. It is going to increase our heat stress on the early stages of our next crops here, and it's going to give us a lot of a potential early season issue. Now, why this is happening and why it continues to happen throughout the month of June. In fact, this is June 4th through July 4th, looking at that temperature pattern, is because the jet stream continues to practice avoidance with the western part of the United States. You know, it's kind of like it's following COVID protocol, right? But it's not saying 6 feet away, it's staying 600 miles away. And the consequence of that is the heat comes back and our moisture stays away. Now, just to show you what we watch for, the hottest Junes through September on record feature large ridges in the flow of the jet stream here and very warm ocean temperatures just off our coast. We tend to have troughs in Alaska. Well, what do we see coming up? Well, it's a little different projection, but this is a trough in the jet stream, and there's our large ridge over the west. That is why we're going to go into a June time period where we expect to have much above average temperatures. If summer was going to cool down for us, we'd have to have a lot of cold water off the west coast and a lot of warm water developing into an El Nino in the central Pacific Ocean. Our coolest summers on record here have those features. Well, what do we have right now? We don't have an El Nino developing. We have a fading La Nina. And this cooler water right here is about our best chance at preventing extreme summer heat and drought. The longer we hang on to those cooler waters off the coast, the better the chances are of the drought being in the Midwestern part of the United States rather than in the West. But you saw earlier, we already have extensive drought across the West that must be undone before the effects of this could really bring benefit. And the warmer water you see here, if it encroaches closer to the West Coast, that increases our drought risk moving forward. That is a major, major part of this upcoming forecast. As I mentioned, this is not going to be an El Nino or a La Nina summer. The forecasts are to take it right back here to 0 over the next 7 months. There's pretty good spread in the forecast, but those ocean temperatures, well, they're not going down into La Nina territory, which is down here, and they certainly aren't building up here toward El Nino territory either. We see what we call INSO-neutral conditions developing. So we come back to this, and as we wrap up my part of the talk today, let me stretch this out into a longer term forecast. You see that cooler water in atmospheric science speak is called the negative phase of the Pacific meridional mode. Pacific Ocean, meridional meaning north-south, and it's the mode of it suggesting that that cooler water is going to increase drought risk in the midsection of the country, increase heat risk in the midsection of the country, and is historically correlated with less extreme heat in the West. Now you're going, wait a minute, the colors don't look like what you just said. That's correct, because this is the correlation with the Pacific meridional mode. Therefore, if the PMM is negative, flip the colors. There is risk of drought and heat as we get into July, August, and September in the midsection of the country. And that would alleviate the risk in the West. And if I could just stress to you again what I'm watching for here, it's these cooler ocean temperatures that give us the negative Pacific meridional mode. So what am I trying to say? Unlike a year ago, if I would have been invited to give this talk a year ago, I would have been much, much more well animated and a bit more upset because we didn't have this cooler water. It was all warm and the risk was huge last year for drought. This year, it's a little bit different scenario. So what are we seeing? This is the forecast for June, July, and August from the best model in the world. It's called the ECMWF, the European model. Now, what we notice is the temperature anomalies, so comparing to normal, and you now know what normal means, looks to be hottest in the central to northern plains and in the Pacific Northwest. While we will just naturally have a hot summer, that's normal for California, the risk of it being extremely hot is minimized. Then look at this. The model right now is projecting in the midsection of the country the greatest risk for regional drought development. The models have been hinting at a very active southwestern monsoon this year, which we know brings in around this area a lot of summer thunderstorm activity. Now, we love and hate them. They can deliver rainfall, but they produce a lot of lightning, which can induce fire. And given our drought situation already going into the summer, that's going to be of a risk. But this is the best early signal I've seen in a while for a more active southwestern monsoon. And I'm going to watch it develop day by day, and I'll keep you up to date and up to speed on what it's going to do. I'll show you exactly where to go to get that information. Just so you know, the models we run in North America, they too try to keep the greatest heat in the interior and the driest conditions in this wedge right into there as well. And if I show you the last update here, this is from the IRI group out of Columbia University. They want to keep the hottest conditions parked over the Four Corner states. Yes, it does encroach through the Great Basin toward California, but the driest conditions seem to be farther to the north. And they too are projecting an active southwestern monsoon this year. So what this means is our drought scenario currently painted for us means that our risk moving forward is already elevated. And in the near term, we're dry and we're going to go over hot going into June. But looking at their longer term, those ocean temperature patterns, which we now know the longer term history of them, but where they currently sit this year, at least pull back a bit on the risk of it being an extremely hot and dry, like record-setting summer and early fall. And to be honest, that's good news. But you should all know that long-range weather forecasting is speculative. And that is why we at Nutrien want to give everybody today on this call something free. If you're interested in keeping up with this, you can sign up for my free national reports at that website at the top, info.nutrien.com/Snodgrass. That's my last name, _weather. I'll put it in the chat so you have it. Every morning, Monday through Friday, I release a national report. You can click on it and see what I'm thinking about, see video analysis if you want to watch them, but also get access to all of my maps, including those important maps that talk about soil moisture, evaporation, and drought. This is free, folks. This is no obligation, and you can cancel at any time. In fact, you could delete it any day you want. I don't care. My feelings won't be hurt. But I want to tell you what I know what's going on with the weather so that we can monitor these things together. Now, my time, it's 5:40 here locally in Illinois. Looks like I got about 5 minutes for questions. If there are questions, if you can unmute or put them in the chat, whatever you want to do, but I'm ready for your questions if you've got them.
Thank you very much, Eric. That was great. Okay, so I see one question in the chat. How early in the year are you able to predict what the growing season will be like in regards to potential water?
Sure. Yeah, that's a very challenging question. And the reason why is because what we have to look at is what our water resources came out like during the winter. So honestly, by the time we get to March, we check reservoirs, we check snowpack, and we're going to know what to expect this season. Now, we do get a southwestern monsoon. We do get some summer thunderstorm activity that can increase that moisture. I won't know what that's going to look like till mid-June, maybe even almost as we get into July. It's the fact that sub-seasonal forecasting, that's anything from like day 15 to day 60, is almost impossible to understand in advance. And therefore, predictability is always low. That's why I produce a daily report. Let's just watch it together evolve on a 2 to 4 week cycle, and you can stay ahead of those changes. The reality of it is long-range prediction is speculative at best. I see another question here. If I can just go ahead and go after it. This is from Ben. It says, what drives water temperatures? Oh, Ben, amazing question. So the atmosphere and the ocean are a coupled system. And off the coast of California, the California current, and also what happens there along the equator, a lot of that is driven by the interaction between the westerlies and the trade winds. So that's the top water. But there are deep water ocean currents that are controlled by salinity and basically our continental shelves. And those ocean currents are driven even by the rotation of the Earth, plus some other larger factors controlling the poleward gradient and those temperatures. So normally on the West Coast, we have upwelling. We tend to be cooler along the West Coast. That's the California current. But that heat increase in the North Pacific, where the heat has just been taken in, and yes, it's anthropogenic. It is the anthropogenic warming of the ocean has just given us, I mean, we got a name for it. We call it the warm blob there in the North Pacific, has just been overruling a lot of those longer term ocean currents. And yes, I'm most concerned about that than almost anything else in the Earth's atmosphere and climate system, even a bit more than what I see happening in the Arctic. Ben, that's a fantastic question. I appreciate you asking that one.
Okay, thank you.
Yeah.
Great presentation.
I'll put this link in the chat, so anybody wants to use it, you can use it. Again, this is no obligation. I won't sell you anything. I'm going to give you the weather for free, okay?
Thank you. There's one more question. Top suggestion to help fight climate change.
Oh, mercy. So let me put it back to what Oli said a few moments ago. Resilience. If you asked me what the most important factor in resilience is, it's managing soil health. That is that's worldwide. Whatever we can do to allow the soil or to help the soil do what it does best in terms of nutrients, in terms of moisture retention, in terms of organic matter, makes it more resilient to these changes. California faces something that the rest of the country does not, in that you've got nearly 40 million people. You lead the country in the production of over 40 different fruits and vegetables that everybody else around the country consumes. And your water resources are limited. The aquifer, the depth of that water to reach it is changing. We know that sometimes we got to go down over 2,000 feet to find water. We know that our reservoir system built on snowpack and drainage to the rivers has tremendous demand. Anything we can do to the soil health to keep it more resilient and retain what it needs to retain makes us more efficient with less, because the world counts on California's production. Everybody knows that. And it is something that I think in the future is going to become stressed. Outside of another 2-hour lecture on that topic, I think that's the most important thing.
All righty. Well, thank you, Eric. I think that closes up our time. We really do appreciate you joining us, especially 2 hours later in the day. I don't know if you can hang around a little longer. We're going to have a longer Q&A period later on, but that's up to you since you've had this time with Q&A. I want to address a question in the chat. Oh, Kelly's already or Julia's already taking care of it. Yes, we are recording and we will have these available to you in a couple of weeks. Within a couple of weeks is our plan. So thank you. We'll go ahead and introduce our next presenter. This is Ben Faber. He is the Soils, Water, and Subtropical Crops Advisor out of UC Cooperative Extension in Ventura County. Ben, are you ready to share your screen?
Yes. Okay. So I love pictures. I love weather. Come on, there. And I think that was just a great presentation. Thank you so much. So my talk is more of boots on the ground. You know, what happens when all these air streams hit us? And we've always had irregular weather patterns, but it seems like it's going nuts now. It seems we're going through patterns of heat and cool and keeps going. And along the coast here, and when I refer to the coast, I'm talking about Southern California, and I'm not sure exactly where Southern California starts and ends, but you know, some people say it starts from San Francisco south. Anyway, along the coast, we have different weather, and one of the characteristics is that, you know, we'll go from these beautiful days. And so today I was out chopping down trees, and I built up a sweat. But you know, 2 days ago along the coast, it was foggy and dreary, and I grew up in Fresno, and I like sun, and it was really disappointing. So the thing is that this pattern that used to be kind of established, that, you know, it was bright days in January and then June gloom and in June, is all been disrupted. We're getting these other patterns that are unpredictable as far as I can tell. So these irregular weather patterns have always made it difficult to assess an irrigation schedule. So, you know, the growers that are along the coast probably can handle water management better than just about anywhere else in the country, because they're having to adapt to this changing weather. And it's the sun, it's the wind, it's the temperature, it's the humidity that drives water use in plants. And when we have overcast conditions, you've got to adjust the irrigation, otherwise you over irrigate. And then if you don't you know, change it when the sun comes out, you're going to under irrigate. So it's kind of like you can't really irrigate on a schedule, although some people do. This is the cumulative chilling hours in Santa Paula. Santa Paula is a little town here in Ventura County. Chilling hours are the number of hours below 45 degrees. And that's an important characteristic that we look at for weather characteristic that we look at for deciduous trees, you know, apples, pears, plums, that sort of thing. When we have mild winters, when we have low chilling, we don't get very much flowering and fruiting. When we have cold temperatures, we have much more flowering and fruiting. And it turns out, you know, our dominant avocado variety, Hass, requires somewhere between 50 and 100 hours of chilling. So you cannot grow Hass in Florida. It's too darn hot. It doesn't get cold enough in the wintertime. You know, I get calls from the Philippines and and Thailand, we want to grow Hass. Well, unless you can get some chilling hours, you're not going to grow it very well. Anyway, the coolest winters have not really, our coolest winters, which have happened just recently, also coincided with two heat events. Back in November, we had a heat event, and then at Christmas, we had a freezing event. And this is crazy. You know, trees don't adapt very well to situations like this. We also had a Santa Ana condition that kicked in February. I think the wind was howling through here. And it turns out the Santa Anas now are occurring just about every month of the year. So you used to have a clearly defined period between October and March. So our weather patterns are just not very stable, or not as stable as our memories of them are. So here it is, the transverse range, and this goes up and down the coast from San Diego to pretty much near San Luis Obispo. And this is partly why the Santa Anas can be so devastating, because the winds come howling down these canyons and go all the way out to the Channel Islands. Channel Islands are a continuation of the transverse range. And so here we have, as clearly colored in by Eric, you know, these weather patterns that drive the Santa Ana winds, and they just come howling out, and you know, these winds are in excess of what a lot of fruit can handle on trees. Historically, we've had about 15 days in the wintertime. You know, when I talk historically, I'm talking about 1970. We'd have 15 days where we'd light smudge pots. And first of all, some counties don't allow smudge pots to be burned now. We use wind machines and water. Last year we had 2 freeze events. They were not catastrophic. The last big one was 2005, and then prior to that was 1990, and boy, that was a doozy. But we've had 2 heat events in the last year, both above 100 degrees, and these were catastrophic. We had over 118 degrees in some places. And the impacts of that heat is you get a lot of fruit drop. What fruit stays on is reduced in fruit size. You get reduced photosynthesis, you get root death, and you get floral abscission, which is going to impact next year's crop. So you're knocking the fruit off with the heat today, but you're also affecting next year's crop. So, you know, these heat events are events that we just did not deal with in the past. So this is what drought and heat events look like. Here we have what's called bacterial blight. This is affected by lack of water. This is Dothiorella. This is a disease that shows up with heat stress, and it's, you can often find these scarred areas embedded in wood from, you know, several years ago. Slowly the new good wood grows around it, making a weak spot in the wood. This is Dothiorella blight. It's a leaf disease. It's associated with the Santa Anas and the heat spells that we're getting. We actually get, you know, when 118 degrees hits, we get terminal death. This is black streak. This is a pretty shocking disease that will show up within a week after a heat event. And then you'll see this is actually sunburn that's occurring from sun heating up the fruit. And here's sunburn damage on the tree itself. So these wind events, the cold events, defoliate the tree, they expose wood, and then that wood then becomes heated up with the leaves are actually transpiring. Transpiring meaning they are acting like a radiator. They're cooling off the leaf, and when they're transpiring, they're moving water through the leaf, and that water is coming up through the xylem, through the woody tissue, which is pulling it through the roots, which is pulling it out of the ground. And when you lose leaves, as happens after a wind event or a heat event or a freeze event, that water's not moving through the tree, and you'll get the trunk heating up, and you'll get sunburn. And people have been bringing material into our office here just in the last several weeks, showing heat stress, where, you know, basically it's the leaves are heating up because they don't have enough water to transpire and cool themselves off. Okay, so Eric was talking about the fires that occur. These fires are carrying particulates, of course, but they're also carrying gases like ammonia and ethylene. And it's hard to tell exactly what's in those fires. You ask, you know, Air Pollution Control District and the Ag Department, and it's not clear because every fire is different. But this is what can happen after a fire. This is not heat. This is actually ethylene that's been released during the fire. And so ethylene is a gas, a naturally occurring gas that causes maturity, ripening. And so these fruit actually ripened on the tree and fell off. We also have just the heat that occurs from the fires, but it's also the ethylene that, and you can see this drop of fruit that's occurred here on the pixie mandarins. And those were not heated up. Those were just from the smoke, the gases that were in that smoke, composing the smoke, caused the fruit drop. So what are we doing about heat? Well, this is an example that comes out of Australia, where they're doing overhead irrigation. And we're going to have an avocado meeting here coming up next month on how to do overhead irrigation to cool air, and not just the air, but also the leaves, to reduce the temperature effect. This is the main way that we as growers can affect temperature in orchard. We're using mulch. Mulch can cool the soil, which can be a problem in a winter when we want some heat in an orchard. But more and more growers are using mulch for various reasons, for adding nutrients to soil to improve the ability of plants to fight off disease, but also for cooling the orchard. And we're looking at using shade cloth. This is not commonly used, but it's being more and more used, and it's basically a material that improves, reduces the amount of sunlight coming into an orchard. This is very commonly used throughout the Mediterranean and South Africa, where it does get much hotter here than here. Cover crops are being used to reduce temperatures in orchards. You know, the relative humidity is going to affect temperature. With a cover crop, you're putting more moisture into the air, and that does reduce temperatures. That can be a problem in the wintertime. It's always been an issue for a lot of growers in Southern California, where we grow crops that are, you know, very sensitive to cold, and growing a cover crop in the winter can cause a little bit of problems. Also putting in windbreaks to reduce the intensity of hot, dry winds. And they also create humidity, which helps reduce temperatures. And we're also turning to pruning to reduce tree size. It actually reduces the amount of water use by the plant, but in theory, it improves water use efficiency by improving the amount of crop produced per tree. And then we always, this is like pruning, you have to whitewash in order to reduce sunburn damage, because once you remove leaves, you remove the radiator of the tree. You know, once you lose leaves, you are going to reduce the ability of the tree to cool itself. So you got to paint the tree in order to reduce the probability of sunburn damage. Okay, so protecting trees from heat events starts with optimum orchard design and healthy trees. You need to irrigate correctly in order to produce an orchard that's going to produce good fruit size. Use the irrigation systems to achieve the best results, both for cooling as well as for fruit production. We're mulching trees. We're monitoring soil moisture and air temperatures to know. Just turning on an irrigation system when temperatures are going up is often too late. You have to anticipate incoming temperatures to make sure that the tree is well hydrated. This is where, you know, turning to Eric Snodgrass's forecast is really going to be important. You have to irrigate prior to the heat event. You know, irrigating during the heat event helps a bit, but it's best to irrigate prior and get the tree well hydrated before the heat event occurs. And there's been some discussion about using protectants and anti-transferants. Sometimes they offer some degree of cooling, but we're still not sure about how well they work. So that's it. Any questions, or are we moving on?
Hi, Ben. Are you able to stay on for Q&A in about 5-10 minutes? Okay, great.
Yep.
Thanks. Let's save the questions for then. Again, if you have questions for Ben, please type them in the chat box and we'll address them in just a few minutes. Kelly, I believe, is going to share my very limited slides. I again apologize. This is a very last minute change in agenda, and I did not have time to prepare what I would consider a proper presentation. I will work on fine-tuning this a little bit better, and we'll be including the updated slides as well as all of the resources and maybe some additional ones that I don't get to today, but I'll be sharing all of that on our Symposium website. And that'll be coming up at the end, my last slide on here, and then we'll also put it in the chat box as well for you. So basically, wildfire preparedness for ag enterprises. If you have been in San Diego County, you know, even as late as recently as last year, you're familiar with the threat of wildfire. It's an ongoing year-round situation that we need to be prepared for, and the more planning we can do in advance, the better. The more we know about how our families, our homes, our personal residences, as well as our businesses may be impacted, the better we'll be able to plan for those events. So not all of the resources I share with you may be directly connected to San Diego County, but there will be components to those resources that are applicable to San Diego County and or may be applicable to recovery, so that you know what you might need to be planning for in the event of a wildfire. So unfortunately, like I said, we're not a stranger to the situation. The small photo here on the, or Kelly, are you sharing my slides? Yep, okay. The small photo you see there is of a burned orchard, and yeah, it's devastating to see the impacts. My own family farm was impacted by fire when I was a teen. So I know how it really affects not only your small business, your family business, but your family itself. So next slide, please. The first thing you might want to do, if you haven't already, is make sure that you can be contacted in the event of an emergency. So up here on the screen is the URL for readysandiego.org. That's where you can access lots of information, but specifically the Alert San Diego information is where you can sign up for receiving information in the event of a wildfire, any other information. There's alerts about flooding and storms, earthquakes, so on and so forth. So that small red San Diego County with the check mark, kind of on the upper left there, that is a application that you can actually download on your phone. And so you'll get updates really quickly on your phone. But there's all these other social media, email communication opportunities that you can be alerted. So I would recommend that you sign up in some way, shape, or form so that you can be reached to be alerted of any kind of an emergency. They'll also share with you updates if there's a fire, how the fire is moving, if there's any evacuation orders, if they're recommended evacuations or if they're mandatory evacuations. They'll let you know if there's any particular shelters for yourself and your family, or for your farm workers, and or for your livestock, pets and animals. So that's the first slide. So next slide, please. All right, so I'm just going to sit on this slide for a little bit, just some pictures, some wildfire pictures. I wanted to share with you, developing a farm emergency plan before a disaster can help you respond more rapidly and objectively in the event of a wildfire. A lot of the recommendations that you would hear for wildfire preparation for your personal property, for your home, and for your pets can just be broadened and applied to your business. And also, if it's, remember to apply it to if your business, your farm enterprise is in multiple locations. So if it's about hardening your home, if you have a business building, a packing facility, any kind of structures, storage sheds, so forth, on your farm, you might consider those same types of structural hardening recommendations that are given for home for those structures in your farm. One article, again, I'll share all these resources and links with you later on the website. But one article I found, it was a blog article, and it was taken from the Foothills, UCCE Foothills area, but a lot of good information and links there. But one of the first things you can do for planning is a fire risk assessment and record all your findings, assess, what the brush buildup situation is around your farm, the road access, evacuation routes, defensible space, what kind of topography. We know fire climbs rapidly, moves rapidly up hills, and we know we have a lot of agriculture on hillsides here. What are the water resources? What plans might you need to make for very critical issues regarding any of those? Like, do you need to do some regular or massive brush clearing, and how and when will you be doing that? Also, evaluate your current insurance coverage. Make sure as much as possible you have adequate coverage for your farm assets, including your crops, livestock, buildings, and equipment. Keep up-to-date production and marketing and financial records. There's a lot of planning tools to do that, but then once you have those, download them to a separate USB flash drive and keep that in a safe location there. It's easily accessible in the event of a fire. Have a farm communication plan. What happens if you're not home or it's in the middle of the night during a disaster situation? Do you have phone numbers? Do you have good relationships with all your neighbors? Are the phone numbers written down? How are employees going to be contacted? have that farm emergency plan developed. Use the, there's lots of free online templates. Again, those will be part of the links that I have up on the website sometime later tonight. I'll get those all up for you. Another thing you might be able to consider is mapping out your farm or ranch. Notate any homes, barns, or outbuildings, utility shutoffs, power and utility lines, fuel and chemical storage, roads and bridges, any weight limitations associated with those, water sources and delivery systems, gates, including combinations, fuel breaks, any other possible farm hazards. You may include, also if you have certain general guidance or notes for emergency responders, for the fire authorities or firefighters, you can also notate those on the map as well. And there's a good example of this on this blog article that I will be that I'm referencing right now. Tools and machinery. Carry fire extinguishers and fire tools, especially in off-road vehicles. CAL FIRE requires a 5-gallon water supply and a fire tool to be carried in wildland settings. So you might consider making sure that that's readily available in all of the toolboxes or in accessible in multiple locations on your farm. Conduct frequent inspections of your farm machinery for debris removal. Pay attention to hazards associated with exhaust systems and catalytic converters, because just one simple spark can, in the right conditions, can spark a wildfire. Rodent deterrents, because they can chew through electrical insulation. Limit or postpone machinery use during a high fire danger, like red flag days. If use is unavoidable, how are you going to address your operation during those red flags, those high fire risk days? Would you be able to complete all the tasks by 10 a.m. while moisture levels are a little higher or before the winds really kick up? When using machinery during more fire conditioned weather, it's recommended that you stay around the machinery 30 minutes after it's shut off. Stay in the near vicinity to make sure there's no fires, no embers, or nothing is sparked after that time frame. It's recommended that you conduct an annual fire plan and equipment refresher. Look at your plan, make sure everything's current, update anything that's needed, train your farm personnel, your managers. Consider labeling safety equipment and fire tools. This can also be added to the map if you create a map. Signs for your employees. Make sure they know how to use all of this fire safety equipment. Again, red flag days. What's the routine for operating during those days? Delaying use of machinery. Also, if there's high heat hazards, there's those situations that need to be considered for your farm workers. So I already talked about Ready San Diego or Alert San Diego. That is on the Ready San Diego link that we shared just on that slide previous. There's general emergency preparedness information on that, again, for just general residents in the county, but there's also a business resources tab that has some general resources as well. It's not industry specific, but it includes information for impact assessments and business continuity. How are you going to get up and restart your business if your business is caught in the wildfire? There's also just an insurance discussion forum. There's also a wildfire hazard map tool, and I'm sorry I wasn't able to get a screenshot of this ready for you. But again, I will have that on the map, but it's an interactive map. And you can type in your address of your business or multiple addresses if you need to see what severity zone you are in, your farm business is in. It'll show you the fire history, the fire stations. You can change the base map. So if you really want to see how those conditions, like geography, slopes and so forth, are in other areas within the county. So you see how fire might move towards your business. You can look that up. Once you enter your address and click on it, it'll zoom you into your address, and there's a pop-up that tells you what your severity zone is, your water district, which I imagine you would know already, links to general planning resources. But it's an interesting map, and I encourage you to check back on our website for this link and take a look. It could be helpful in your planning and assessment. The Western Center for Agriculture, Health and Safety, based out of UC Davis, is addressing the safety and health of ag workers. There's a lot of resources on that. In 2019, the state adopted a regulation, protection from wildfire smoke. So it is required that this information is shared with employees, and that they have a training. There's lots of resources available there, both in English and Spanish. So we'll have links to that, to the actual regulation if you really want to read those details. But there's training posters, and there's a training discussion guide and a checklist, like I said. Regarding agriculture workers, this isn't specifically wildfire related, but I noticed that the Western Center for Ag Health and Safety, as part of their monthly seminar series, is having a heat-related illness and injuries, climate and practical solutions for ag workers. It's a webinar. It'll be Monday, June 7th from 4 to 5. So I'll include the link into that webinar also if you're interested in that. Let me see, what other resources did I want to share with you real quick. Surviving Wildfire is a website available through e-extension. That's a nationwide online cooperative extension resource. There is a website specifically geared towards wildfire. During a fire, there's, during the tab of During a Fire, there's information and resources about evacuation preparedness for livestock. That's something that's concerned. Oregon State University has small farms, local foods, and wildfires information. Let me see what else I can share with you. California Department of Food and Ag, of course, has some information regarding wildfire, mostly information regarding links addressing disaster assistance and risk management assistance or insurance programs. So, you know, your USDA, your Farm Service Agency, NRCS, so different institutions and organizations, and links to information to help you with that. Also, Ready, Set, Go, Wildfire Preparedness for Farmers, Ranchers, and Growers. This is a publication. The Ready, Set, Go publication is a pretty widely adopted publication throughout the state of California. It's developed by, the original was developed by CAL FIRE. But Ventura County also adopted it specifically for farmers, ranchers, and growers. So I'll have that link available for you so you can check that out. Again, we know San Diego County agriculture is not exactly like Ventura County, but there may be some tips in there that are helpful for you. Let's see what else. So much more locally, besides the Ready San Diego, the Ready San Diego website and the Alert San Diego information, I would also highly encourage you, if you're not already, is to see what are the local wildfire plans or preparedness plans in your community where your businesses are located. The Fire Safe Council of San Diego has local community fire safe councils throughout the county. And one of the things they tend to work through the membership is developing community wildfire protection plans. So either your local fire authority having jurisdiction in that community, or your local fire safe council, or there may be some other local community organization that I'm not aware of, but you know, investigate what are the current plans. You know, is the evacuation route, one of the primary evacuation routes from the community, the frontage road for your business? You know, how are you going to be impacted by that? And what are the access, the ingress and egress accesses to your property? Also, last year during our Climate Action and Ag Symposium, Ben Faber had talked about mulch resources, but he also shared some information regarding how mulch can help reduce, conserve water, but it can be flammable. And during wind-driven events, which many of our fires are, most of them, the most damaging ones are wind-driven events. So slight embers can fall on that top-level mulch and catch fire. Also, some mulches you can have weed issues. Weed seeds are in the mulches, and you can have weed issues, even though mulch is intended to help reduce weeds. But weeds, once dried out, can be another cause of fuel in the understory of your crops. So consider that. So I will link to his resource from last year that had links to more information about mulch and wildfire. And then last month, again, the County of Ventura, UCCE in Ventura held a 3-day webinar series regarding climate change. What does it mean for Southern California? And there's several great presentations on there. I'll list the entire series for you on the website, but one of them was specifically about fire and rangelands and livestock. So there's Matthew Shapiro, an advisor from that area, shares some information. Okay, so there's so many other resources, and I apologize. I'll have them all listed. There's some that are specific to avocados and to other university sources that may be relevant for our area. I will list them on the website, so please do check back either later, tomorrow morning, probably the best. Next slide, San Diego Gas and Electric. So this is a more local resource for real-time the wind conditions, the wind speeds, the current temperatures, and the relative humidity. You can click on any of these weather stations. San Diego Gas and Electric put this system together after I believe it was the 2003 firestorms. So it's some real interesting information. If you want to know what's going on near you can zoom in on this as well and get closer to the location of your farm. Also, as part of this SDG&E weather system, next slide, Kelly. List just more of a just by the weather station. There's multiple stations throughout the county that they reference, but not only the winds and the gusts and the directions, but the temperature and humidity are listed there too. So there's that. So the next slide, it's a lot of information I just kind of spilled out verbally to you. Again, I apologize. This is the URL, I'll put it in the chat, but this is where every year, kind of on the home page for each year's symposium, we do list all resources. That is going to be a growing list as we go on throughout the week, but I will work on getting all these resources up tonight. So if you want to check back tomorrow and you're interested in any of those, or feel free to contact me. Hopefully you all have my email. It's on the first slide. You'll have it in some communication post the symposium. So right now we have a few more minutes. I'd like to go ahead. I actually spoke longer than I'd planned, but I'd like to see if there's any more questions in general for Ben or in general. Let me see if I can find Kelly. Thank you for sharing the slides.
The only question that came in is this one from Oli that just came in, this last one. And it's for Ben.
Okay.
In the chat.
Let me
just got it.
Not open. Oh, okay. For Ben, while overhead irrigation may reduce crop tissue temperature and water vapor from the leaves during excessive heat, wouldn't it be exposing a crop to more susceptibility to pathogens and cause crop scalding, heat burn from water getting hot on leaves? Could these be a concern for tree crops?
Good question. And number one, sun scalding is not going to happen because this is water that's going on continuously, and so sun scalding is just not going to happen in that situation. But remember, we're a Mediterranean climate and we are typically dry. This is not Florida. This is not, you know, an environment that gets a lot of rainfall. We typically do not have any fruit diseases or leaf diseases. And Oli, this is a really great question, because we are not doing overhead irrigation continuously. We're not trying to create Thailand or Philippines or anything like that. You know, we're doing this for, you know, on a, you know, a 2-day event or 3-day event, maybe a 1-day event for that matter. So it's not a prolonged wetting of the leaves and fruit. So, you know, the consequence, the several growers that I've spoken to that have put in these systems are only running them when it gets really, really hot. You know, they're looking at 100 degrees and higher, and it's for a short period of time. So they're not continuously irrigating with overhead. And that would be an issue if it were a continuous overhead.
Okay, any other questions? We have a few more minutes.
Jen, if you want, I can go over the continuing education while people are typing out their questions.
That'd be great. Thank you, Kelly.
Okay, hold on one second. Let me get it open. Okay, so where did it go? Share this one. So again, for continuing education, we had certified crop advisor credits today. If you have the CCA app, open it up on your phone, take a picture of this, and it should automatically log your hours. If for some reason you can't do that, it's having problems, or you don't have an app, you can send me an email, ANR program support at ucanr.edu. I think Julia will put it in the chat real quick and just tell me, hey, I was there, I need CCA credit, here's my information, and I'll get you signed up. I'll leave this up on the screen, and otherwise, Jane, you can, if people have questions, we can take them, and I'll leave this up while you guys are talking.
Isn't technology wonderful?
Yes, sometimes. Most of the time. I noticed, Julia, thank you, Julia, you went ahead and already posted our symposium documents URL in the chat box. So that's the one you can check back on throughout the week to see what resources have been posted, and also that will be the pages with the links to the videos once those are ready in a couple of weeks, and as well as a summary publication. So tomorrow we will meet again. I hope you can join us. We will be discussing irrigation management, which is a great concern always, but especially now that we have these forecasts of extreme drought coming our way. And then the next day we will be discussing not only water quality, but nitrogen management in different growing situations, and then pest management, and then we'll have a bunch of updates for local programs and projects in soil health on Friday. So feel free to contact me if you have any questions. My email, I'll go ahead and post it here. Otherwise, we will look forward to seeing you tomorrow. Let you out a couple minutes early today.